So we spent some time learning how to balance a chemical reaction because our chemical reaction really is our recipe for everything we're going to make in chemistry. It tells us how much stuff we need to mix to make a certain amount. It tells us what's going to form. It gives us a ton of information. Now in this video, we're going to learn how to use that information to actually calculate how much of each reactant you need, or to calculate how much of a product will form. Okay? So if you notice, step one was to balance the equation. If I don't have a balanced chemical equation, I can't do anything. Okay? So I'm going to have a chemical equation. What I'm going to do then is I'm going to change the mass of what I know. I'll either know the mass of one of my reactants or one of my products, but I'm always going to be starting with grams. I'm changing the grams of what I know to moles of what I know. Okay? Once I change moles, or change it to moles of what I know, I'm going to change it to the moles of what I want to know about using a mole ratio. Okay? That will tell me the number of moles of my desired reactant or product. Once I have moles of what I'm trying to find out about, I'm going to change those moles back to grams, but this time it's my new reactant or my new product. Okay? Sounds a little tricky, but it's always the same order. Okay? Here we've got our diagram of what we're going to do. So if that makes more sense, you can follow it graphically. But here's what it's going to look like. I've actually given you the balanced chemical formula, so we don't need to balance it first. If it's not balanced, always make sure to change that first. Okay? So I'm told that solid lithium hydroxide is used in space vehicles to remove exhaled carbon dioxide from the living environment by forming solid lithium carbonate and liquid water. I want to know what mass, so how many grams of gaseous carbon dioxide, so this is the one I want to find out about, can be absorbed by 1 kilogram of lithium hydroxide. So I know that I've got 1 kilogram of this. Well, in all of my steps, it was talking about changing grams to moles, moles to grams, nothing about kilograms. So the first thing I need to do is I need to change my kilograms to grams. I've got 1.00 kilograms times, remember, because I'm starting with kilograms, kilograms go on the bottom. I'm changing it to grams. Hopefully we memorize this prefix kilo. There are 1,000 grams in every 1 kilogram. So if I have 1 kilogram, I've got 1,000 grams. Okay? So I'm starting with 1,000 grams of lithium hydroxide. Now, I'm being a little sloppy right now, and I'm not keeping track of my significant figures. I'm going to make sure that when I get to my end, I round my answer to 3 significant figures because that's what I started with. But because I have all these zeros, I'd have to use scientific notation. I'm trying to make life a little bit easier, so I'm ignoring that now. Okay? So step 1, I need to get rid of grams, so that goes on the bottom. And my steps said I was changing that to moles. Okay? So I know that 1 mole is always equal to the number from the periodic table. If I look on the periodic table, lithium weighs 7, oxygen weighs 16, hydrogen weighs 1, so the whole thing weighs 24 grams. Okay, so that's step 1. I need to keep going. Step 2, I need to get rid of moles of lithium hydroxide. So moles of lithium hydroxide goes on the bottom. Instead of lithium hydroxide, I want to find out about CO2. Now the way I determine my mole ratio is from the balanced chemical equation. I need to find out about lithium hydroxide. Well, if I look at the equation, there's a 2 in front of lithium hydroxide, so I put a 2 here. In the balanced chemical equation, there's nothing in front of CO2, so I know that's a 1. Okay? So this is my mole ratio, and I get my mole ratio from the equation. In step 3, I need to get rid of moles of CO2 because it asked me about the mass or the grams of CO2. I know that 1 mole is always equal to the number from the periodic table. So if I look at the periodic table, carbon weighs 12, oxygen weighs 16, and there are 2 of them. So 32 plus 12 is 44. So that's what goes on top. When I plug this into my calculator, 1,000 times 1 divided by 24 times 1 divided by 2 times 44 divided by 1. I can ignore all of the ones because they're not going to change my number. So 1,000 divided by 24 divided by 2 times 44. I should get 916.666667, something like this. Remember, I only started with 3 significant figures. 1, 2, 3. I'm going to cut it off there. Because this is a 6, I round up. So it becomes 917. Everything canceled out except for grams of CO2. Okay? So take a second and try example 14. In example 14, we're told that NaHCO3, which is baking soda, is often used to neutralize excess stomach acid, HCl. I want to find out how much HCl can be neutralized by 1 gram of NaHCO3. So what I should have done is I start with 1.0 grams NaHCO3. Okay? Now because I'm starting with grams of NaHCO3, grams of NaHCO3 go on the bottom. In step 1, I'm changing this to moles of NaHCO3. I know that 1 mole is always equal to the number from the periodic table. If I look at the periodic table, Na is 23, H is 1, C is 12, O is 16, I have 3 of them. 16 times 3 is 48, plus 12 is 60, 61, 71, 81, 84. So I've got 84 grams of NaHCO3. Okay. Step 2, I'm getting rid of moles of NaHCO3. So that goes on the bottom. I'm changing to moles of HCl. Now remember, when I'm changing from moles to moles, I look at the balanced chemical equation. In this case, I've got no number in front of NaH, so that's a 1. I've got no number in front of HCl, so that's also a 1. Okay? Last step, I need to change moles of HCl, so that's going to go on the bottom, because the question asked me about grams of HCl. I know that 1 mole is always equal to the number from the periodic table. H is equal to 1. Cl is equal to 35. So the whole thing weighs 36 grams. Okay. When I plug this into my calculator, 1 divided by 84, I ignore all the ones, times 36, I should get 0.42857. In this problem, I started with 2 significant figures, 1, 2. Because that's an 8, I round up, so 0.43. I'm left with grams of HCl. So I can neutralize 0.43 grams of HCl if I take 1 gram of NaHCO3.